Okay, so today we're going to look at patterns, similar to what we've been doing on warm-up, except we're going to look at a variety of ways to express these patterns or show these patterns. So we can see pictures. We can have explanations with like words, so we can do sentences or paragraphs to describe a pattern. You see here we can fill in a table of data. We'll be graphing on the backside. We can also write our pattern as a sequence, similar to what we did on number 1 on the warm-up. Or we can write it as an expression or an equation. Okay, so we're going to do a lot of different things with these patterns today. So where I want to start, it says problem 1 up at the top, a pattern of small squares is shown below. Use the pattern to respond to the following questions. Okay, so this is what I want you guys to do together with your partners. I'm going to give you a lot of instruction up front, so make sure you're paying attention close here. I want you to draw figure 4. Okay, so you're going to draw figure 4, and then you are going to fill in 1, 2, and 3. And on number 1, we're going to use the first column as figure number, and then the second column is going to be the number of squares. Okay, so I want you to first draw figure number 4, and then I want you to do 1, 2, and 3 with your partners, okay? Can you handle that? Okay, draw figure 4, do 1, 2, and 3 with your partners. They'll give you about 5 to 7 minutes here, so go ahead and do that. Okay, so figure 4. So I'm going to just redraw figure 3. I'm going to try not to mess it up too bad. It's hard to draw on this thing. Thank you. Okay, and then in addition to figure 3, remember I need to now draw 1 down here and 1 up here. Hey, don't laugh. Don't be bullies. Hey, don't bully me. All right, so I'm just kidding. All right, so on number 1, okay, so now I want to fill in the figure number, and remember I'm finding figures number 1 through 5. And I need number of squares. So how many squares are on figure 1? 4. What about figure 2? I have 1. Shh, please. 2, 3, 4, 5, 6. Then I have 8. Then I have 10. By a show of hands, how many people drew figure 5? Okay, so a handful of you drew figure 5, and that's how you found out how many squares were in 5? Figure 5? 12, right? How did the rest of you figure out how many squares were in figure 5?
Found the pattern.
You just found the pattern and you followed the pattern, right? What'd you say? Common sense? Okay, following the pattern. All right, so then number 2 wants us to take the number of squares, and now we're going to write a sequence. Okay, so all I'm doing is taking 4, 6, 8, 10, and 12 and writing it in a sequence. This sequence then, really, it's kind of helpful. You can figure it out from the table of data, though. Does the sequence have a common difference? So really quick, take 30 seconds with your table and talk about what a common difference means. I'm not talking about what the common difference of this is, what a common difference means. Go ahead. How do you identify a common difference? Just explaining in general. Okay, so what is a definition that we came up for a common difference? Yes, you are...
It's a country.
Ireland.
There we go. You're the first teacher to guess it.
Nice.
Adding or subtracting the same amount of time, or same amount each time.
So it's the number that we add or subtract the same each time? Okay. Anybody else have a different way of saying it? Yes, sir. You are? David.
It's a pattern that doesn't change.
Okay, a pattern that doesn't change. That's a good way of describing it, okay? So what is the common difference here? Good, plus 2 each time. And it's important to put the plus or minus, right? So I have plus 2 this time. Okay, so I have my sequence. I have my common difference. Now it says how many small squares would be in the 10th figure. Justify your response using the sequencer table. So I would just probably start my table at 5. And at 5 there were 12. At 6 there were 14. 7, I would keep counting up. How many do I get at the 10th figure? 22. Okay, so I get 22 squares at the 10th figure. What if I then ask you a harder question and asked you to tell me how many squares there would be in the 100th figure.
100
Multiply by 2.
100 times 2?
It's 104.
So, hold on. Based on your theory, you say we should multiply it by 2 each time. Well, what about when there was one figure? Did we just multiply by 2?
104.
Okay. So it doesn't quite work that way. It's going to be a little tougher. Okay. Would you want to take your table and extend it out and put 1 through 100 and figure out count plus 2, plus 2, plus 2 until your finger falls off? No, I wouldn't want to do that either. So instead, let's do number 4 together. It says use the variable n to write the expression that can be used to determine the number of small squares, even if I wanted the 100th or the 1000th figure. Okay, so what we're going to do is we are going to use our table of data to write the expression. So I go to my table of data and I ask myself, how is my data changing each time? So each time the figure number goes up 1, how much does my number of squares go up by? 2, right? So my common difference here is plus 2, plus 2, plus 2, right? So I can either figure it out from my table of data or from writing out my sequence and finding my common difference that way. Either way, that number becomes your multiplier. So you'll want to put that, oops, I put that on the wrong number. Can I take this? No, hold on. I'm trying to figure out how I do this.
Undo button.
Yeah, I guess I could just erase it. All right. Oh, it cut out all this. That didn't work very well. Oh well. Okay, so I can find my common difference either way. That becomes my multiplier. Okay, because now on number 4, I start to write my equation. I am going to use S as the number of squares. And I know that each time my figure number changes, how much does my data change by? 2. So I know that every time my n figure number changes, my pattern needs to go up by 2. So I'm going to multiply that figure number by 2. That's what it means to be my multiplier, because I'm taking 2 times the variable. Okay? But I need to make sure that my equation is complete. I need to make sure it's fully accurate, and it is not quite yet. Okay, because look at my data up back in my chart. Figure 1, I should expect if I plug in number 1 for the figure number 1, I should get out 4 squares. What happens when I plug in 1 here? 2 times 1 is 2, not 4. So it's wrong. 2. What if I plug in the number 2? I should get 6 out. If I plug in 2, 2 times 2 is 4, not 6. So my data is not exactly accurate. The 2n gets me close. You are Abby. You okay? So I need to add 2 to my equation to make it perfect. Multiplying by 2 got me close. Now let's see what happens if I add 2. So let's now go back and recheck my data. You have a question, Stephen?
I was going to say that plus 4.
Okay, so let's look at my, what'd you say?
Plus 4.
Well, I wouldn't want to add 4 because that would make it too big.
Oh.
So let's look at 2 and check our data, okay? So if I go back and check, figure number 1, if I plug in 1, 1 times 2 is 2, plus 2 more is 4. That is the expected number of squares. So my equation is right so far. Let's check another point. Let's check down here at figure number 4. So if I plug a 4 in, 4 times 2 is 8, plus 2 more is 10. I am expected to get 10 squares. So that's a good equation now. So now you're going to take your equation, and I want to give you about 30 seconds to answer 5 with your partners. Go ahead. Okay, so it is important here, guys, to make sure you know what it is asking you and what it is giving you. Okay, so I'm going to ask you a question, so you got to listen carefully because it's kind of a tricky question. Is it saying it wants you to find the number of squares in the 20th figure, or does it want you to find the figure number when there are 20 squares?
20th figure, how many squares in the 20th figure?
How many squares in the 20th figure? So what piece of information does it give you? N. In my equation, n is what it gives me, right? It gives me the figure number, so it gives me n. That's important because I need to know where to plug in the data it gives me and what I need to get out. So here I have S equals 2 times my N is 20 because I'm looking at the 20th figure, plus 2. So 2 times 20 is 40, plus 2 more is 42. So S equals 42 squares. And then back to the original question that I asked you. Remember I said, do you want to find the 100th and fill out the table over and over and over again? You all said no. That was a good answer. S equals 2 times the 101st figure plus 2. So 2 times 102, or sorry, 2 times 101 is 202, plus 2 would be 204. So S equals 204 squares. Okay? Everybody good with that? Okay, let's flip it up. Okay, around on the back here. A little bit of a different problem, but pretty similar in a lot of ways. So I'm going to start it with you because it's a little bit tricky in the start, and then I'm going to let you rock and roll and do what you do. Okay, so problem 2 says Springboard Mobile charges $20 for the base data plan. How many times are you charged that $20? Once. One time you're charged $20 for the base plan. Plus $8 for each gigabyte of data you use. Okay, so then number 6 says, complete the table below showing the charges. So for 1 gigabyte of data, how much are you charged? $28. How did you figure that out?
Add 20 plus the 8 for 1 hour.
$20 base charge, $8 for 1 gigabyte of data. So I could write over here, gotta get my pen. 20 plus 8 times 1 gigabyte of data. So that's $28. What about 2 gigabytes?
36.
Is it 16?
36.
Is it 36? Or should I take 28 and multiply it by 2?
You can add it. Just add it. So it's 36. It's 36. Just add 8.
Are you sure it's 36 or is it 56?
36.
36.
Why would it not be? So this is a discussion you're going to have in your group. Why do we not use 56? Why is it 36 versus 56? I'll give you 20 seconds. Go ahead. Good. I heard a lot of good things. Most of them along the lines of you add $8 each time for the gigabyte, but you don't have to add $20 every single time, right? So I wouldn't just double it and get 56. I would just say, okay, $20 one time plus $8 times 2 gigabytes of data, which would give me 36. All right, I want you to finish the page with your group. So I'll give you about 10, 12 minutes here to finish the page with your group. Go ahead. Okay, here we go. All right, so then for 3, I should have 44. 4 gigabytes, I should be charged $52 and $60 for 5 gigabytes. Guys, always remember when we're making graphs, you always want your input, in this case, the number of gigabytes, to be your x-axis. So I put gigs down here. And then you always want your output, which in this case is the total charge, to be your y-axis. So this is charge. I'm not going to put numbers on it. It should look something like that. It should be a straight line. It should be increasing. Yeah, I expect you to put numbers on it for ease and quickness. I'm just going to do that because I know you guys know how to graph points. All right, now we want to write a sequence. It starts at what? 20, what? 28. So 28, 36, 4, thank you. On and on and on. Okay? What is the common difference, or how does my pattern change? It's going up by 8, so plus 8. And remember, now I take this number, and what does that number become in my equation? The multiplier, right? I have, let's see, so I'll say T for total cost equals, for every time the gigabyte changes, my total cost goes up 8. So I have 8G. But then I got to figure out, what do I need to add or subtract in order to make it perfect? So I go back to my data, and I plug in a point. So if I have 1 gigabyte of data, so 8 times 1 would be 8. I want it to be 28. So how do I need to change? Plus 20. Let's see if that holds true. So let's try another point. Let's try down here at 3. So if I plug in 3, I should expect 44. So 3 times 8 is 24. Plus 20 more is 44. So that's good. Then I use my expression to figure out for 10 gigabytes. So my total charge should be 8 times 10 gigabytes plus 20 is 80 plus 20. That's a total charge of $100. And if you did 32 gigs, I'm sure your parents would not be very happy with you. So 8 times 32 gigabytes of data plus 20. 8 times 32, anybody?
276.
276 plus 20 more would be 296.
Oh, wait, no, I meant 276.
Oh, so it's
32 gigs.
so 8 times 32 would be 256,
Yeah.
and then plus 20 is the 276. Okay, thank you. Okay, that's all right. All righty.